Hey! Hey! We're here to talk about the periodic table, the basics of the periodic table. We're going to talk about organization first. One of the first things we're going to do is we're going to see that this periodic table has columns and it has horizontal rows. Right? One of the important organizations is the horizontal rows that are called periods. And if you have a periodic table with you, you might pause this video and label some horizontal rows as periods. The other organization on this periodic table are the vertical columns, and those are called groups or families. You'll sometimes hear those words used interchangeably. So the horizontal or the vertical columns are called groups or families. You'll notice on this periodic table, some of the groups are color-coded with the same colors. Right? That actually has meaning, and we will talk about that later on in another video. Hey, whoa, geez, keep stepping on this spring here. The next thing we're going to talk about on the periodic table is the idea of shells. And from the Build an Atom simulator, you guys notice those blue rings that surrounded the nucleus, or the place where the protons and neutrons. We call those shells on the periodic table. I'm going to show you a way on the periodic table where we can figure out how many shells an atom has and then how many electrons in each of those shells there's going to be. So on the periodic table, we see these horizontal rows. We call them periods, right? And each period has a number right over here that we can see. Right? Most periodic tables have these periods numbered. Right? That number basically tells you how many shells an atom in that period will have. So I can see right here, these two atoms, or these two elements, are in period 1. Right? Both of those, if I were to draw a model of those, will have just one shell. Right? Hydrogen will have one shell with one electron in it. Helium will have one shell with 2 electrons in it. And if you think back to that Build an Atom simulator, we'll see that that first shell only holds 2 electrons. Hey, here you are again. So we talked about the number of shells each element in each period will have. Now we're going to talk about how many electrons go in each of those shells. As I said earlier, this period will have one shell. And it fills up with 2 electrons. So I can use the periodic table as kind of a cheat sheet to figure out how many electrons each shell will hold. I can see, using the periodic table, that the first shell holds 2 total electrons. Okay? So when I fill that shell up, we have to go to the next shell. Right? So when we're building these atoms, these models, the next shell out, we start filling up electrons. And if I look, I can see that this shell would hold 8 total electrons. And that shell does in fact hold 8 electrons. Those electrons on the outer shell, we're going to actually give them a name. Those electrons are called valence electrons. I'm going to actually write that vocab term here. This is a word. I'm going to define that for you. It is the electrons found in the outer shell. I'm going to show you a trick here in just a moment of how we can figure that out really quick by looking at the periodic table. Hey. All right, so we talked about shells and valence electrons, or electrons in the outermost shell. Now we're going to actually take a try at maybe drawing a model of an atom using the periodic table as our guide. All right? So I'm going to have a partial eclipse of the periodic table here, and I'm going to be looking at beryllium. Right? And so we're going to focus here on this element, beryllium. I can see that it is in period 2, group 2, right? And I'm focusing in on this number here. Beryllium is the atomic number of 4. So I'm going to assume it's in a neutral atom, which means it has 4 protons and 4 electrons. All right? So as mentioned earlier, I can see that I'm actually going to write the symbol in the middle. And that's going to represent my nucleus, because we're just really kind of focusing on the electrons. Because what we're going to find is that in chemistry, all the magic happens with electrons. Right? The chemistry we do in here will all be dealing with how electrons share or are given up or taken. So beryllium has a total of 4 electrons. I know I need 2 rings or 2 shells to hold those electrons. That represents the first shell. This represents the second shell. And I know beryllium's in the second period, so it's going to have 2 rings. As mentioned earlier, the first shell holds a total of 2 electrons. Remember, I have 4 to put on here. So that first shell will have 2 electrons. And the next shell will only have 2 electrons for a total of 4. 1, 2. And this actually represents a pretty good functional model of the electrons in a kind of simplified model of beryllium. Right, so we can see a total of 1, 2, 3, 4 electrons, 2 in the first shell, and only 2 in the outer shell. Right? And this is what we're going to be doing with the Play-Doh when we build models, or what we did.